Respected ma'am, sir, I am Suraj of batch 11. The topic I chose to explain is merge sort. First of all, what is sorting an array? If we start with an array in which the left half is sorted and the right half is sorted, we can merge them into a single sorted array. We need to copy our temporary array backup. This process is called merge sort. An example has been given. Uh, Merging parts of a single array. The procedure is really no different if the two arrays are really portion of a single array. We took an array and divided them into two portions, first part and second part. Merging two sorted arrays. To merge two sorted arrays into a third sorted array, repeatedly compare the least elements and copy the smaller one of the two. Now I have taken an example of two arrays. First, I started by arranging with the least value of both of the arrays. Together, I arrange them in an ascending order. So, what is recursion? The left. How did the left and right halves of our array get sorted? Obviously, by merge sorting them. To merge sort an array, merge sort the left half, then merge sort the right half, then merge the two sorted half. Each recursive call is with a smaller portion of the array. The base case is merge sort an array of size 1. This is the code required for merge sorting. The merge method. The merge method is too ugly to show because it requires the index of first element in the left subarray. It also requires the element in the right subarray and also the index of the first element in the right subarray. That is the dividing line between the two subarrays. The index of the next value in the left subarray also requires the index of the next value in the right subarray. And finally, it also requires the destination in the workspace. Conceptually, it is difficult. It isn't difficult. Let's do an analysis on the merge operation. The basic operation is compare two elements, move one of them to the workspace arrays. This takes constant time. We do this comparison n times, hence the whole thing takes order of n times. Now we move the n elements back to the original array. Each move takes constant time, hence moving all n elements takes order of n time. So the total time taken to move elements is order of n plus order of n is equal to order of n. So far we found that it takes order of n times to merge two sorted halves of an array. How the question arises? How did these arrays got sorted? At the next level down, we had four subarrays and we merged them pairwise. On the basis of example, since merging arrays is linear time, when we cut the array size in half, we cut the time in half. But there are two arrays of size n by 2 in the above example. Hence, all merges combined at the next lower level takes the same amount of time as a single merge at the upper level. So far, we have seen that it takes order of n times to merge two subarrays of size n by 2, order of n time to merge four subarrays of size n by 4 into two subarrays of size n by 2, and also order of n time to merge 8 subarrays of size n by 8 into 4 subarrays of size n by 4. The question arises, how many levels deep do we have to proceed? How many times can we divide an array of size n into two halves? It's log of n base 2. So if our recursion goes log n level deep and we do order of n work at each level, our total time is log of n multiplied by order of n, or in other words order of n log n. For large arrays this is much better than bubble sort, selection sort or insertion sort, all of which are order of n square. Merge sort does, however, require a workspace array as large as our original array. Now, a stable sort algorithm. A stable sort algorithm keeps equal elements in the same order. This may matter when you are sorting data according to some characters. Example: sorting students by test scores. This is the example I have taken to show a stable sort. Now, an unstable sort algorithm. An unstable sort algorithm may or may not keep equal elements in the same order. Stability is usually not important, but sometimes it matters. This is the examples: student name and marks. Is merge sort stable? Recursive merge sort does none of the actual work of moving elements around that's done in merge. Stability of merging. Stability of merge sort depends upon the merge method. After all, this is the only place where elements get moved. Same, I arrange them again in ascending order. The given example. Wow, the question arises: what if we encounter equal elements when merging? If we always choose the element from left subarray, merge sort is stable, or else it is unstable. Thank you, ma'am. That's it.